evening, guys. Thank you for passing by my channel once again. I am Asel Foku, uploading you with a new video from Asel Educate. Subscribe to my channel and hit the notification bell so that whenever a new video like this one is released, you shall not miss a step in it. Okay, without wasting time, as you can see on the board, we have limits and differentiation. Limit and differentiation is a topic we've treated before. If you've been going through my channel, you will notice that this topic has featured there before, but it was on the paper. And it wasn't really clear. For you to watch the previous video I did on this particular topic, you need to put enough data because you will be watching it on high resolution to actually view what is on the paper. So when I watched at it, I thought it wise to do a new video on the same topic so that those who don't have access to a lot of data can also watch and enjoy it. So guys, like you are seeing, you are noticing, we are talking today on limit and differentiation, and we are based on limit because as you can watch, differentiation is a topic on its own and limit is another topic, but they are linked with limit and differentiation. So these two concepts are applied here, but today we are talking on limit, and to be specific, we are talking on the limit of a function. The limit of a function, any function you're giving, you look for the limit of it. So guys, like we are saying, if you watch on the board what we have written, I define the limit of a function, like the limit of the function f of x at a is the value of f of x as x approaches a, and is written as limit as x tends to a of f of x, which is equal to f of a. I don't know whether you understand something here. This is simply telling us that wherever in the function f of x we have x, we shall be putting or substituting the x with a. I will explain better when we get to examples. Friends, the formula in simple terms is telling us this. Wherever in a function, take for instance, if we have f of x, x squared minus 2x minus 2, assuming this was f of x, it simply means wherever we have x, like we are seeing x here, x in this function, we substitute it by a. A can be any constant. You substitute by a to have this. If you have not understood it up to this level, just watch till we take an example and take another example. You should understand better. Look at something again. They say to evaluate the limit of f of x as x tends to a, we simply substitute a in the function f of x. Like I was saying, we take an example. The example says evaluate the following limits. Evaluate the following limits. And just to make you understand something, me myself, it has been a problem. It was a problem to me when I was, for everybody, before anybody start doing whatsoever he is doing, he spend time to learn it. It is true some people are born genius. Yes, I understand and agree with that. But what we are saying is this: nobody is born perfect. No. If anybody begins doing what he is doing very well, it's because he mastered the concept behind that thing. And for you to master the concept behind anything, give yourself for that thing and learn it. So what are we saying? In every question given you, understand what they want you to do. And in this our case, we are asked to evaluate the limit of the following function. And what do we know about limit? If you are given the limit of a function, f of x for example, we are asked to fit a in f of x wherever we have x to have this. Okay. Like I was saying, if you haven't understood up to this moment, don't bother yourself. As we take examples, you shall certainly understand. We have the first example, which is a. Limit as x tends to 2 of x squared minus 2x minus 2. That is our first example. We shall quickly be going to that. But before, you write the solution. Solution. And the first example is a. What does it say? Limit as x tends to 2 of x squared minus 2x minus 2. That is our first example, guys. What do we do here? Think of the principle you have learned. The principle says, if a function is given as f of x, wherever in the function f of x we have x, we substitute it by 2. That is what it means. Okay, watching out our function and the limit. And another thing, in our function, what is a? What is a? Because the function says, the formula says, pardon me, the formula tells us that limit as x tends to a of f of x is equal to f of a. What is our a in that example? If you are wise enough, if you are smart enough, you will quickly notice that our a is 2. This is our a. In that case, it is 2. So, we shall be putting a in the function f of x wherever we have x. So, coming back to our example, we shall be putting 2 in the place of x in the function f of x. It means in this function, wherever we have x, we shall be replacing it by 2. So, applying that, what do we have? We shall be having 2 squared minus 2 into 2 minus 2. What does this give us? It will give us 4 minus 4 minus 2. And you will quickly notice that minus plus goes away, neutralize, and it becomes negative 2. That's our answer, negative 2. So guys, as simple as this is, in this level it is still very simple. But these are the small tips in the beginning of every topic you shall learn and understand it fine, so that by the time it is applied in complex equations, in complex function, you shall not be confused. You shall not be asking yourself, what is happening? In every function, there are small tricks. There are small. It begins very simple, but as you advance, as you go further, things become bulky. Things begin to expand, and these small tricks we learned in the beginning is what will be applied. So, in everything you are asked to solve, just think of the principles you've learned about that particular topic and struggle to apply them. It is not magic. You know, sometimes when an equation is given you, like for example, if you watch at our second example, which is b, you will notice that instead of a straight something like we had here, a linear something like we had here, we have a fraction. We have 6x minus 2. Let me just write it very fastly. We have limit as x approaches negative 1 of 6x minus 3 on all over 5x plus 4. You will notice that in our second example, instead of a linear something that we had here, we have a fraction. And by the time you watch at it, you become, what can I do? This is. Don't think like that. Just remember the principle you've learned about what is before you. And once you're able to memorize the principle or understand, once you understood the principle and it is in you, just apply it. And what is the principle we've learned in this case? We've learned that anything given to us in this form, once we see this, we know that in the function f of x, wherever we have x, we shall be replacing it by what? By negative 1. So that is what we will apply here. That is what is expected of us here. So what are we doing? We shall quickly apply it. We have 6 into negative 1 minus 3 all over 5 into negative 1 plus 4. That is what we shall be having there. And this will give us, negative 6 minus 3 all over 5 into negative 1, negative 5, let me wipe like this so that it will be clear, into negative 5 plus 4. That is what it will give us. What does this give us equally? It gives us negative 9 all over negative 1, and which is equal to 9. That is our answer, guys. So we just need to apply the principle. Once you're applying the principle, you see everything coming out to be clear. So that is it, guys. So in every equation you are given, just remember to apply the principle you've learned so far concerning the question before you. Guys, if you've watched up to this moment, why don't you subscribe? Subscribe to my channel, as there are more of these to come. Remember, we've written on the board limit and differentiation. It's a full topic, it's a whole topic on its own. And we just took limit, and limit, we are not even done with limit. We just took an introductory subtopic, which is limit. And we shall be talking on our next class of the L'Hopital's principle. De L'Hopital is a French mathematician who talk much on what we are dealing with at this moment. So we shall be looking into his principle, on how we can actually use this principle to solve equations like this, because there are conditions for his principles to be applied, which we shall be talking of next time. So not to miss the next video, make sure you subscribe to my channel, hit the notification bell, so that when the video is released, you shall be the first to be notified. If you like this video, please hit the like button. Thank you for watching. See you next time. Bye bye.